So there are a lot of tricks to divisibility, and we'll take a look at a few here. Sometimes they're called divisibility tests. And what that means is you can look to see if a number is divisible without actually dividing. So with the divisibility test, we usually don't actually divide. We don't carry out any kind of long division. And my guess is you guys know a whole bunch of divisibility tests. Like if I just write up a number here, like 1020, just by looking at that number, can you tell me some of its factors? Let's see, Amanda says 3 is one of the factors. Ooh, interesting, that's a tough one. Jimmy says 2 is a factor. 10 is a factor. 5 is a factor, says Montse. Okay, so we can just look at that and say, hey, yeah, that, like it ends in a 0, right? 10's a factor. It ends in a 0, so 2 is a factor. 5, similar idea. 3, how do we know 3 is a factor? Amanda, do you remember the reason why? Oh, Michaela says 20 is going to be a factor. Ooh, that's interesting. Explore that one. The sum, Amanda writes. Yeah, so you can tell a number is divisible by 3. So here's the trick for 3. If you haven't seen it before, divisibility by 3. Add the digits. So for example, here I would take 1 plus 0 plus 2 plus 0. Adding 0 is kind of boring, but what the heck. 1 plus 2 is 3. If the sum is divisible by 3, the original number is divisible by 3. That's the way it goes. And that's a pretty cool trick. All right, so let's see. There was a claim that 1020 is divisible by 20. So I'm familiar with the reason for 2 and 10 and 5, but I don't know if 20 is as common a reason. So why would 1020 be divisible by 20? Anybody have a reason for that? It looks like it ought to be, but why? How could we justify that without actually doing the division? So everybody can put their minds to thinking about that. I don't want to actually divide. Okay, let's see. 100 is divisible by 20, and 100 times 10 is 1,000. Yeah, so Michaela's kind of breaking this up into a couple of problems to justify the divisibility. So 1020, and I agree with your reasoning, nice job, is equal to 1,000 plus 20. And 20 definitely goes into 20. And if we're sure that 20 goes into 1,000, if it goes into both pieces, it must go into the whole thing. And it turns out that's a general rule related to sums and divisibility. And so it goes like this. If A divides some number B, and A also divides some number C, then A is going to divide B plus C. And that's kind of what she's getting at with that one right there. There's another hidden rule in there too that I'll go over. So this turns out to be kind of a general rule about divisibility, and we'll look at a couple of examples of this in just a moment, but you definitely want to make a note of this. It's in the book too. You should see it in your reading. Another rule that's kind of going on, so that explains this part right here in Michaela's reasoning. This part right here, that is related to a rule, let's use a different color. If A divides B, then A is going to divide any number times B. So hence 1,000 being a multiple of 20. So that's kind of related to that other one. So we'll look at some examples of that too. All right, so I think I'm going to come back to these general rules and pick on specific numbers like 2 and 3 and 5 and 20 and so on. So let's regroup here. And look at some divisibility tests. So the divisibility test for 2, anybody want to take a stab at what that is? You can either text or try to speak. All right, so I don't think anyone posted yet. I wish Zoom would tell me when someone's typing. That would be nice. So for 2, there's a couple of ways to think about it. Often people say, well, a number is divisible by 2 if the number is even. Well, how do you know if the number is even? And it turns out we can look to see if it's even. And usually what we say is it ends in a special digit. That digit could be 0, 2, 4, 6, or 8. So these are the even single digits. If any number ends in 2, 4, 6, or 8, then the number is going to be divisible by 2. So that's the test for 2. 3, I just wrote on the other one, the sum of the digits is a multiple of 3. So if we happen to recognize that. 4, does anyone know of a test for 4? For example, is 1,334 divisible by 4? Or 5,612, is that divisible by 4? Is there a way to check without actually dividing? It's kind of related to the divisibility rule for 2. Actually, it's very related to the divisibility rule for 2. Ends in an even number. So that is an excellent guess, and some, like, an idea that might lead to that is 2 divides 4, and 2 has that test right there, but it turns out I can't take that kind of thing backwards. So for example, this number ends in an even digit 4, but if I actually tried to do the division there, 4 goes into 1, 3, 3, 4. I'll use that short division technique. 4 goes into 13, 3 times, remainder 1. 4 goes into 13 3 times, remainder 1, but 4 does not go into 14 evenly. It goes in there 3 times, remainder 2. So it's not just enough to have an even digit at the end there, but it's close. Let's check on the 5,612. Does 4 divide 5,612? And I highly recommend calculators. I don't feel like switching screens at the moment. So let's see, it's red. 4 goes into 5 once, remainder 1. 16 4 times, remainder 0. 4 goes into 1 no times, remainder 1. 4 goes into 12 3 times, remainder 0. Okay, so it did go into 5,612, but not 1,334. So just that 4 wasn't sufficient. And it turns out just the 2 on its own wasn't sufficient either. That digit also is important. Okay, so I'll state the rule and then I'll try to justify it. So the rule is that the number ends in a 2-digit multiple of 4. Another way to state that is the last 2 digits are a multiple of 4. Okay, why that works we'll get to in just a sec here. So if I look back at the numbers I gave, then 4 does not go into 34, so it's not going to go into 1,334. 4 does go into 12, so my claim is that it does go into 5,612. Now I showed it with division. I'm going to try and show it without division. And so it's kind of similar to what Michaela came up with earlier for her reason that 12 goes into 1,020. I can look at the 5,612 as 5,600 plus 12. Now, 5,600 is really 56 times 100, and then plus the 12. And I know that 4 goes into 100 because it's 4 times 25. I just happen to know that. And most of you probably know that too. And 4 goes into 12, so that means 4 goes into the whole thing because the 4 has been divided out here and divided out there in that part of the sum. So I'm using back here these 2 generic rules to make a new rule. So I had to put a couple rules together to make that happen. And the rule for 2 is actually pretty similar. So for example, 2 is going to go into either of these numbers here. Let's pick on the 1,334. So 2 divides 1,334, because we can view 1,334 as 1,330 plus 4. Now I recognize that 2 goes into 4, because that's a simple fact I've memorized. As far as the 1,330 is concerned, and I'm sorry if I wrote that too low on the screen. If anyone's having trouble with their Zoom, I'm going to move up here. 1,330 plus 4 could also be written as 133 times 10 plus 4. And I know that 2 goes into the 10, and I know that 2 goes into the 4, so 2 must go into the whole thing because it's been divided out. Does that make sense? Do you want me to explain that a little more, or are you kind of getting where I'm coming from there? Somebody can give me a thumbs up, or I don't get it yet, or both. Got 1 thumbs up, 2 thumbs up. Getting it, okay, and we're going to keep practicing this, so don't worry. Okay, I'm making some progress, you're making some progress with me, cool. So we have a reason for 2, a reason for 3, a reason for 4. The explanation for 3, I think I'll wait till next class to give that explanation. It's a little trickier than the 2 explanations I just gave. Let's move along. 5 ends in 0 or 5. And it's a similar justification in terms of a sum for that right there. And let's see, 6. Does anybody know a rule for 6? Since people are searching through their memory banks, hoping something's going to pop up. How can I tell if a number is divisible by 6? Does 6 go into 1,334? Does 6 go into 5,612? I'll give you a hint. 6 is equal to 2 times 3. So it turns out for 6, what we do is we test for 2 and we test for 3. So if it ends in a 0, 2, 4, 6, or 8, and the sum of the digits is a multiple of 3, then 6 will go into it. So we could check that out for 1,334. So if it ends in a 4, so it's even, right? And then if we add the digits, 1 plus 3 plus 3 plus 4, that gives us, on a good day, 11. 3 does not go into 11, so 6 does not. 6 does not divide 1,334. So if we use that straight bar with a slash through it, that means not divisible. Okay, so 6 does not divide 1,334 is what this says right here. All right, 7, it turns out there are divisibility tricks for 7, but it's easier to actually divide. So there is no good test for 7, in my opinion. Any test for 7 usually involves subtracting multiples of 7 from the number, which is essentially what division is, right? We went over that last quarter. 8. Has anyone ever heard of a divisibility test for 8? So I'll give you a hint. 8 is similar to 2 and 4. And we want to take a guess by looking at the rules for 2 and 4. Let's see, I don't see anything in the chat yet. Okay, so 8, the last 3 digits, the number formed by the last 3 digits has to be a multiple of 8, which in my case isn't too useful, but it's kind of like the 4 was the last 2 digits, 2 is just the last digit, 8 is the number formed by the last 3 digits. So number, I am going to explain this one. Last 3 digits is a multiple of 8. So let's go to a new page and explore 8 for a minute. So I'm just going to make something up and show that it works and then try to explain why. So 8 goes into 24. So 8 would go into 240. So there's a 3-digit multiple of 8. And again, the reason is if 8 goes into 24, 8 is going to go into anything times 24. So I can put any digits out to the left that I want, like 1, 3, and 5. So my claim is that 8 divides 135,240 because I know 8 divides 240. And we could check that. Now I'm going to get a calculator just for fun. So what was my number again? 135,240. 135,240 divided by 8, we should get no remainder, we just get a whole number. Okay? So that did work, but the question is, well, why did it work though? What the heck? And who's up on their 3-digit multiples of 8? I'm not. I can do 8 pretty good up to, I don't know, 96, and then I kind of lose it after that. Meaning 8 times 12 is 96, a good day. So let's see, why does this work? Remember we have a base 10 number system? And what that means is each digit here is more than just the digit, its place means something too, right? Like that 5 right there is in the thousands position, and that 3 is in the 10,000s position, and the 1 is in the 100,000s position. And every one of those places has a power of 10, right? So we have our 1s, we have our 10s, we have our hundreds place next, we have our thousands place following that, and so on. As far as powers go, 1 is 10 to the 0 power, 10 is 10 to the 1st power, and 100 is 10 to the 2nd, and 1,000 is 10 to the 3rd power. Okay. So I'm just going to focus on the 1,000 for a minute. 10 is really 2 times 5. So 10 to the 3rd is the same as 2 times 5 in parentheses to the 3rd power. Well, you might remember a power rule that if you have a product to a power, that means each part and each factor inside is raised to that same power. So that's the same as 2 to the 3rd times 5 to the 3rd. And what is 2 to the 3rd, anybody? On a good day, 2 to the 3rd is 8. Thank you, Jimmy. Yeah, that's really 8 times 5 cubed. Who cares what 5 cubed is? Because we have an 8, and I care about 8 because that's what I'm looking at divisibility for. So 1,000 is the first multiple of 10 that 8 is a factor of. Because 1,000 is 10 cubed, and 10 is 2 times 5. That means we have a 2 cubed in there, which is really an 8. So any place value of 1,000 and above, 8 is definitely going to go into, because there 8 is in there, right? 2 to the 3rd, 2 to the 4th still has an 8 in it for 10,000, and so on. The problem is these 3 digits right here, 8 doesn't go into 10, 100, 8 doesn't go into 10, 8 doesn't go into 1. So the catch is, as long as 8 goes into whatever number is formed by those first 3, I don't care about the rest because 1,000 has an 8 in it. So breaking this number down right there, that would be 135,000 plus 240. Right? 135,000 is really 135 times 1,000. And I know that 8 goes into 1,000. Oops. If 8 goes into 240 also, then the 8 divides out and I get a whole number. Okay? So 8 goes into 1,000, 5 cubed times, according to my work over there. So that means if I actually carry out this division here, 8 goes into 1,125 times. 8 goes into 240, well, let's see, 8 goes into 24 3 times, so it must go into that 30 times. And then the answer is whatever 135 times 125 plus 30 is, and there is no remainder, right? Because the 8s have been divided out. So that's why that 3-digit at the end works with 8. And there's a similar reason for 4. If you look at the last 2 digits, that means you're leaving out 100 and above. 100 is 10 squared. 10 is 2 times 5. Oops. which is 2 squared times 5 squared, and 2 squared is 4. So that means 4 goes into whatever number is formed by the digits in the places 100 and above because of that 100 right there, which is kind of nice. Ooh, that was deep. Okay, let's see. I'm going to stop the recording here.